This is a video for MEI Core Pure Mathematics, first order differential equations, 1.5, integrating factor, multiplying by a factor to give a perfect derivative. So a first order differential equation is linear if it can be written in this form. I've got dy by dx plus py is equal to q, where p and q are both functions of x only. If we look at this example here, I can rewrite this as dy by dx minus x squared y is equal to x squared. And so this has minus x squared as my p function and x squared as my q function. So this is linear because I can rewrite it in this form. This one is not linear. When I rewrite it, I haven't got a single power of y, and so I have not got a linear equation. Let's have a look at this differential equation. And the suggestion is that we multiply through by x to get a differential equation that we can solve. Well, let's multiply through by x. I'm going to get that x dy by dx plus y is equal to x cubed. Now look at this left-hand side for a second. This is really just the derivative, d by dx, of xy. Remember, if we differentiate xy, it's a product, so we'll get x times the derivative of y plus the derivative of x, 1, times y. And so my equation becomes that. And this is something that we can solve just by integrating with respect to x. The left-hand side will become just xy, and the right-hand side will become x to the 4 over 4 plus c. And when I work that through to get y, I will get that y is equal to x cubed over 4 plus c over x. And there it is, tidied up for you. This, which is just a derivative of product, is known as a perfect derivative. And this, that we multiplied through by to get this perfect derivative, is known as an integrating factor. And we will look in a later video at how we can work out what integrating factor we need to form a perfect derivative on the left-hand side. Once we have the perfect derivative, you can see we just integrated both sides, and then we tied it up so that we got y in terms of x. So in summary, if we've got a linear first order differential equation in this format, we can multiply through by something which is called an integrating factor to make the left-hand side into a perfect derivative. And once that's happened, the resulting equation can be solved by integrating both sides with respect to x. The next and final video in this section is 1.6, finding integrating factors.